I'm Mike Tetlow. I'm a developer at Bracket Labs, and today we're going to be talking about developing high-performance web apps. So what we're really going to talk about today is what happens in the web browser when you see slowdowns that are related to drawing, painting the DOM. This isn't necessarily a course about writing proficient JavaScript. Sometimes to make the DOM more performant, you actually have to write some counterintuitive JavaScript or hit the DOM in ways you thought you would not have to. So, as I mentioned, I'm Mike Tetlow, a developer at Bracket Labs. We make apps for the App Exchange. Let's jump into it. So generally, this feeling of clunkiness or slowness in the browser is called Jenk. You may be familiar with it if you're scrolling on a page that has a lot of DOM elements on it. There's a lot going on. And you may notice when you're scrolling, it doesn't really have that smooth feeling like you're going through it. You kind of may see some chunkiness. You may also see chunkiness in the middle of doing nothing on the page when there's an operation going on in the background. That could be maybe a JavaScript garbage collection event or something like that. Generally, Jenk is the term we're going to use to refer to all of this clunkiness and the browser locking when you're trying to do something. So we're going to do a few things about this. First, we're going to figure out how to find out if this is our problem. And then we're going to look at some example issues and some resolutions. We're going to look specifically at some layout thrashing, which we'll get into later, and we're going to get into debouncing some events. What debouncing events really means is maybe you have an event that fires multiple times, and really maybe you don't need it firing once every millisecond. Maybe you could cope with it firing once every 100 milliseconds, every 250 milliseconds. So we kind of explained this already, but if we get into a technical term, the human eye really starts picking up Jenk when the rendering rate drops below 60 frames per second. When you're down near 30, you're still doing pretty good. Most television, in the United States at least, is around 30 frames per second, and that looks pretty fluid to us. 60 frames per second is a great goal to shoot for. So this happens, you generally have these 60 hertz refresh rates on both a laptop, a mobile device, pretty much anything out there with a screen. These are good goals to shoot for. So one instance where you will find Jenk is when the browser reflows. This may happen on page load. This may happen when you change something significant on the page, and it goes through all of your HTML, all of your style sheets, lays everything out onto the page, notices how those elements interact with each other, and then those elements are eventually translated into pixels that are drawn onto your screen. They're the right color, they're in the right spot. We did all that with HTML markup and CSS. It's a pretty interesting thing to look at, especially in the back end. So if we look specifically at recalculating styles, we've got, just some example HTML and probably some CSS in there. If not, I'm sure it's going to include. So, it's an XML tree. You have to build that, you have to parse it, and you're taking all of that into account before we drop it onto the page. So especially with a lot of elements, with a lot of styles, even sometimes when you have styles that look simple but wind up being complex for the browser to calculate, it can take some time. So then we have our layout step. This is what happens after we've parsed everything. So this is when the browser develops specifically the size of the elements on the screen, how they'll push each other around. HTML is unique in that, there's a lot of elements that you've got floats, you've got things pushing each other down below the next element. There's a lot of interaction going on here. Generally, that only happens in the same layer. And we'll get into that a little bit later when we talk about maybe some elements should be on one layer and some elements should be on another layer. Then we've got painting. This is when the browser does the work and fills in essentially those wireframes it figured out. So it's going to go in there. It's going to look at fonts. It's going to look at colors. It's going to look at a lot of things. So this is a wireframe. Essentially what it's doing when it's laying out, it's figuring out all the pixels, and then it's dropping all of this text in the correct font, dropping these images on, correct color, pulling the images. Everything winds up looking great. So what really triggers these browser reflows? The first one's obvious. When the page loads, the browser flows. It has to figure out what's going on. But there's a lot of other stuff you can do that makes a browser reflow. I've got a list of JavaScript methods here, and I'm sure it's not the complete list. Sometimes these JavaScript methods will impact just its own element. Sometimes it will go all the way up the tree, trigger a full browser reflow. It's really interesting to look at. The source of this is an article from 2011, so there's probably more by now. So let's jump out of the slide deck, and we're going to look at Chrome DevTools. All right. So let me jump this back down to what we all usually use in Chrome DevTools. When I started really digging into this, I was surprised at the depth at which they've gone through and added features specifically to debug these problems. So what I've done now is I've opened Chrome DevTools, I've moved to this timeline tab, and I'm going to go down here. I'm going to start recording the timeline of what's happening in the browser. So I'm going to record it. I'm going to come down here. I'm going to scroll this overflow div here. It's just full of some placeholder text, not a whole lot going on. But when we're going through it, we see that down on our vertical timeline here, pretty much every time we're sending a scroll event, we're painting that 510 by 510 element on the page. So if you had something very complex in there, and you're scrolling in there, and there's style recalculations going on, you could wind up seeing perhaps some chunky scrolling going on. A great way to find exactly what's going on when you're active on the page is to open this tab right here, the drawer, apparently. So there's a rendering tab in the drawer, and then you're able to go down, and you have several options here that all related to rendering stuff. As a JavaScript and web developer, I got along without touching any of this for a very long time. When I did need to touch it, it was a lot to learn. Hopefully this session can help give you a jump start on that. So we're going to look at paint rectangles. So you can see while I'm doing this, Chrome is going to show me, okay, we're repainting all of this. Now notice when I'm scrolling this entire page, the entire page is not repainting. Most browsers are smart enough to offload the entire content of this several thousand pixel height page I've got to the GPU, and then it doesn't have to go through and recalculate each time it's pulling it in. So that's where using these overflow divs can become unique, because you're not offloading anything to the GPU. Every time you do something, you're recalculating. We also have some more tools down here. We have a frames per second meter up there. At the moment, we're doing pretty good. Once we get into the more broken demos, we'll show that dropping. And then there's also some other helpers that you may find useful, like show potential scroll bottlenecks. And notice, Chrome knows, because this is an overflow div, we're repainting on scroll. That may be a bottleneck. So let's start moving into some more demo. So first we're going to talk about layout thrashing. So this is a very contrived example I've got going on here. All we're going to do is take all of these divs we've got sitting on the screen, and we're going to randomly set them to a width, The width, and the width will impact the overall height of what we've got going on. So I've got two methods here that I'm going to kick off. One is called thrash it, one's called doing it smarter. So let me demo thrash it first. All right. So we can see here, after we captured our event, performed an action, paused our recording so we're not cluttering up our timeline here, we're going to see that something strange is going on in our DOM. On line 157, we're recalculating style, and we're laying out again. We're recalculating style, we're laying out again. We do this over the count of all of these elements. Something's probably a little fishy here, like why aren't we recalculating everything, then doing one layout, or even one recalculation and one layout? So this is pretty contrived, and you can see we're able to go through this in approximately, we start at 1080 milliseconds, and we're going to, it takes, 70 milliseconds or so to do this. But contrived example, I've seen this particular issue take up to seconds if you have a really loaded up DOM, and that's a really bad user experience where you're just locked at the moment. Chrome is generally pretty good about not presenting the user with a message, but they still have a bad experience when trying to click on something within those 2 seconds the browser is locked. So let's take a look at what we're doing in this page. We've got a button, right? Our button ID is thrash me. So here's our click event handler. Very simple, contrived example, but essentially, remember, our business goal was to go through, and when you click a button, you're going to dynamically resize a bunch of stuff on the screen. So all we're going to do is we're going to, on click, we're going to iterate through all of our block elements, which are just our 60 or so elements on the screen. We're going to go into the element, and we're going to get the bounding client rect. So what we're looking for here is the current width of it, presumably to do some calculation on that and figure out the next width, figure out what's going on. And then we're going to set a new width. So we're just picking a random number here. And then we're done. So this makes a lot of sense, right? We're getting the width, we're setting the width. Notice one of the examples on that slide of JavaScript methods that can cause a browser reflow is get bounding client rect. So that's going to make our life interesting, and that's really the source of why we're doing all of those reflows one after another. So if we come back to our page and we try our smarter button, let's look what happens. Remember, we were around 70 milliseconds right, and we recalculate style and a layout for each of these elements. So let me start the recording. I'm going to hit smarter. Go and pause the recording. And let's take a look here. This one is harder to find because it's so quick. So if we take a look here, we've accomplished the same goal with one layout, one style recalculation. Everything happened there. Last one took 70 milliseconds. This one took, I don't even know, let's call it 1 or 2. Oh, there it is on the far right here. Time, 0.277 milliseconds, 0.213 milliseconds. So that's not half bad. So let's look at how we did that. Again, we've just got a button out there. We've got a click handler on that button. we're going to iterate through the same nodes. This time we're going to do a little bit differently. Notice I've got this index to size map. So as I iterate through these nodes, I'm just going to build the list of all of their widths, and I'm going to persist that in memory. So dirt simple, right? Almost the same code. Now instead of setting a width, I'm going to add it to this object I'm persisting in memory. Then I'm going to iterate through these nodes again, and I'm going to pull that width from the object in memory. So what we're doing here is using a little trick that the browsers help us out with. If you're firing a bunch of these events all at the same time, it's going to group them, combine them. What really messes with that is when you change something immediately after you fire an event that would trigger a browser reflow, because that change itself is pushing a flow up. So the key is to group your gets in this situation and then group your sets. So it's a little counterintuitive, right? If you looked at this JavaScript, you'd wonder, why exactly am I doing this? And 98% of the time, you won't have a problem with this. That 2% of the problem, that 2% of the time, it's going to be a tough problem to track down. And using those debugger tools will really help you, because you'll be able to go there, look at the events that are not scripting. You'll see paints, you'll see layouts, you'll see what caused those paints and layouts. You'll be able to look at that and hopefully work your way through a better solution. So I have a few more demos. Got one called Chunky Scrolling, called Scroll Chunky here. So on this one, I'm going to add a URL parameter to it called isSlow. I'm going to scroll like this. So in this particular case, we don't even need the debug tools to tell us that this is a crappy UX. It may be tough to watch, but when you're scrolling and you're actually doing it, it's a very odd feeling, and I can't imagine a user that likes it. But let's get some metrics on it. So we're up here. You see we're dropping down to the point where the browser actually locks, and the frames per second meter drop down to these very low valleys here for a second. So we're actually locking the browser entirely at that point. We've got, 0 frames per second, certain areas. So let's look at the timeline. This timeline is going to tell us what events are doing what. So that's just a quick scroll. Got it finished. A lot of events captured on that one. Okay. So a good way to read this timeline is notice on the right here, you've got 30 frames per second, and you've got 60 frames per second down here. And notice where these events are up here. They're way past that. It's kind of reversed, right? But you get the general idea. High on this particular graph is bad. So let's go through what we've got in here. Okay. So we can see a scroll event firing. Let's take a look at that. So that one is taking about 100 milliseconds, but the interesting thing is there's one right after it, right? And this set of 6 scroll events we captured, was me essentially just swiping down the trackpad like that. That's kind of unique to the scroll event, but you may also see that on some other events like drag and stuff, the handler firing over and over and over, and sometimes you need to do something to throttle that. So in this case, we're going through, we're recalculating style, we're repainting the entire thing, we're going through, we're recalculating style, we're repainting the entire thing, and we're doing that essentially for each scroll event the JavaScript picks up, right? We want to set these colors randomly throughout the entire page on each scroll event. So if we look at the code for that, let's look at what we're doing. So again, somewhat of a contrived example, but it'll come in handy in a lot of different situations, more for just demoing what's happening and how to get around it. So we can see that we've got a scroll changed method down here. And essentially on that scroll change method, we're going to iterate through a set of elements, and we're going to set a background image to a gradient of a random color. So all we're doing is changing background image of a div. And we can see that we're looking for that is slow flag I had on there. And all I'm doing is saying window on scroll, execute this scroll change method. And it's going to pass the event into it. So we're firing those scroll methods one after each other, and it winds up doing it essentially on each event. Kind of slows the browser down. We could probably provide a better UX for that. So what I'm going to do is I'm going to delete this is slow flag. Okay. So now, notice it's a slightly different user experience. We really only change colors when we stop the scroll. So there's that slight lag on it. But at least from up here when you're scrolling it, it's performing much better. It feels much more natural to move around the page. And we have the plus side of not absolutely locking the browser every now and then. So let's look at what we did. On this, we're attaching window.onScroll to a method called lazyScroll. So we're going to use a library called underscore here. Actually, I believe this may be Lodash. They're very similar. And we're going to use a debounce method they have. Essentially, all this method is doing is it's going to set a timeout for these events firing. And if, notice here we have 200 passed in. If 200 milliseconds pass without that event firing again, it's going to fire the scroll change method. So that's that slow lag we saw coming down. We waited for all those events to finish. They came into JavaScript, and we waited our 200 milliseconds, and we updated the DOM. It's that same scroll change method. We didn't change anything with that. We just changed how we called it. All right. So if you're looking for resources on this, there's several great places to go. There's an entire website dedicated to called jenkfree.org. There's a lot of conference talks on there. There's a lot of presentations, some blog posts. There's also a HTML5 Rocks tab for it. So you can go through there and look at anything on there. And we're at Q&A. We have a lot of time left, so I'd like to answer a lot of questions. Yeah.
So we have a lot of content in our web pages that are video, they render videos, and of course sometimes that can, there's a lot of lag when scrolling. So what are your recommendations when you have to have embedded videos in a HTML page?
How are you embedding the videos?
Right now it's just in an iframe.
Oh, okay. I would probably have to look at that one. To be honest, I would start stepping through those dev tools. I would start seeing what's going on. Are you scrolling when the video is playing and it winds up just being chunky?
Exactly.
Yeah. I would also look at the source of what it's playing in the iframe. And I would see, that could almost be like a browser plugin problem if you're looking at Flash. If you're rendering HTML5, I would look at the Chrome debug tools. And I would start looking at what's going on, set your timeline up, start recording, perform the action, pause it, start going through those methods, see if you're repainting something crazy's going on.
I noticed in your example that garbage collection is one of the times that get tracked in the performance tool there. I was wondering if you'd ever observed a situation where garbage collection was an issue. If so, what you did about it.
I have most definitely seen a situation where garbage collection is an issue. And that's an interesting memory management and JavaScript question. Essentially what you want to do is, again, do something that's very counterintuitive to your normal JavaScript learning, and you want to start almost allocating memory on the window so you're no longer causing those garbage collection events to occur. So say you're doing a comparison function of two objects and you're going through it, you may want to think about storing both the two objects you're comparing on the window so they're not collected each time that comparison method runs. And that's, at that point, you know, you're swapping memory out. It's not trying to clean up memory. I've seen garbage collection events pause the browser for 3 seconds collecting, you know, 8 megs of garbage. It's a very interesting problem to troubleshoot. And alloc and dealloc is really what it comes down to. Yeah?
What would be the best optimization if we are running it through the thin clients versus outside of a browser?
What browser do the thin clients run?
Out of the Citrix. Chrome?
Chrome? I would imagine at that point, you know, you're probably GPU starved. You might be a little RAM starved, I would think. I think all of the optimizations really come into play on all devices. Like, we had a desktop demo today. You will see this a lot more often even on large production websites on a mobile device because they're a little more starved for resources. So it's probably the same thing with thin clients. And I would go through those same troubleshooting steps, especially on an existing app if you've never done it. And sometimes you notice Jenk, you know, go through there, troubleshoot it, see what's going on. The main goal of the session was kind of to give you the tools because all of these situations are so different for the business logic, right? You have to go through there and figure out what's going on, why it's going on, and sometimes you need to modify your business logic to make it run better, like how I did with the scrolling, right? All right. Anybody else? All right. Have a great afternoon.